Hi there, welcome to this video. Here today I was working on a unit test in Python and needed to do something that happens even to those of us who've been, like myself, developing professionally for decades. I had to refresh my memory. Yes, a developer who was first exposed to Python and PHP when they came out in the early 90s, and have been using them since, refreshed my memory by opening up the browser. What's wrong with that? How many of us are rewatching movies in preparation for this weekend's big movie release? I know quite a few folks who rewatched Game of Thrones just before this latest season started. So there's no difference when you switch between languages and start doing things that you've not done in a while. But today's problem, mocking a library function, raising an exception, I had to do some refreshing. And so I did Google search, and in the results was a YouTube video I threw up in the background to which I planned to listen while reading the documentation itself. Now, for those of you who've not come across Corey Schaefer's Python videos, I'd highly recommend them. I found that they're a great way to refresh skills that I've not used for several months or years, and I do not hesitate to recommend them. But none of us are perfect, and today I came across something I felt needed a response video. Let's take a look. Here at the 8-minute 30 mark, he's showing writing a unit test for a function, and he goes to show by changing the value what the test looks like when it fails. Over the next minute and a half, he proceeds to build things up where he's got this. And this is where my teeth ended up on edge. Having tested for quite a few years code that runs anywhere from just a few lines of code to a couple 100,000, I found that this violated a basic principle that I'd learned. And that is that each test tests what you're testing, only making a single call. So instead of doing test add and doing 3 calls asserting 3 different conditions, the proper way to do this would actually, or better, there is no proper way. Let's not get into religious words like Emacs versus VI or Windows versus Mac versus Linux. The better way that I've found to do this is to actually test it with separate functions for each of these. Let's take a look at how that looks, why that is. Now, over here, I have the calc function that, or the calc module that he wrote. Kind of threw it together just to show you what's going on. Let's take a look at testcalc.py, which is a version with some modifications of what he did. Now here we see I've set up some failures ahead of time, which will demonstrate why this is actually not a good way to go. And you'll notice up here I also added in a Python env shebang to make things even easier. So this is a little bit further along than he has, but let's see what it looks like when we test it. When we run it, we've got 3 failures. It says 15 is not equal to 14. We've got an error here saying cannot divide by 0. And we've got an assertion down here in test subtract where 5 is not equal to 2. But let's look at the reality of things. Here in test add, we have 2 tests that should fail, not 1. By putting the asserts in this single function this way, the moment we hit an error, it stops testing. End of discussion. It throws or raises a condition, and that particular test ceases. So while we see that 10 plus 5 is not equal to 14, but it's actually 15, we don't see down here that it also failed on the -1 plus -1 equals -3 test, when reality is -2. Now in this case, it's an artificial error where the fault is in the test, not the code, But the same thing would be true if it were the other way around, and we said that in the code that, oh gee, when we get -1 and -1, we'll return -3. And we forgot that. And again, here in test subtract, we have this one here, which fails, and immediately ceases the test subtract function to report that it's a failure, not telling us that this test here is a failure condition here. Now, one other thing he did was he showed mocking the assertion that we actually had the function raising an exception, which is what I was hunting for. Now, he showed just plain old assert raises. My personal preference generally is to use the assert raise, and in Python it would be assert raises regex, to say, here's the error that it's going to do, and here's the message that I expect back. One of the nice things about that is we can actually check to make sure that the message is something that we're expecting elsewhere. So that's the advantage of that one right there. But let's take a look at the revision. Let's count to pi. Here you see I've separated things out. One test function in the test class for each assertion that we're doing on a given call. And so we end up with many more tests. Now, this is not the case of multiplying tests just to multiply them and make our numbers look good. This is actual meaningful changes. When we run this, we'll actually see something different. Let me add a tput reset here to make things look all nice. Notice here we have the results showing that we've got multiple failures, where in earlier tests we were only showing that there was one failure. This is more meaningful because sometimes that'll tell us a little bit more, just enough to help us find that particular bug that we've got in the code. Now, like I said, these are artificially set up to fail in the test, but imagine the code that was supposed to return 14 instead of 15 in this case, or -3 instead of -2 on a much more complex function. And so by splitting it out like this, we actually see that, yes, this test failed, but we also see that that one failed. And likewise down here, we've got our... Now, this is a really simple one, and simple functions, sometimes you'll be tempted to test in this fashion, but more complex ones, this is where it really comes into play. Let's take a look at another program I was working on. Here I have the beginnings of a vault used for storing secrets. And I'm using the libsodium utilities, libraries, to actually store those secrets. I've got two static methods here that I was putting under test. The first method, it hunts for a file for us under the Python search path to tell us, oh, here, I found it here for you, so that we don't have to hard code a path name into the system to go through and find things, and we don't necessarily rely on where exactly things are in the search path. So we've got this function here, relatively simple, but we've also got here OS path join, and we're doing a call to match func. Now I could go through and mock out match func in my test. In this case, I'm not so sure if that's a good thing or not, but as I sit here, what if I pass in something different? Well, we can actually use a mock there, but since this is so simple, I decided to not bother with mocking it. But down here, we see that we've got the call to the other method, and depending upon what it does, we go with the response from here, this line, or we go with the response from this line. Now that's nice, but maybe vault find is, in your case, a function that goes out and creates something on the file system that you don't necessarily want to create, or maybe it's getting the date and time, and your tests don't want to have to sit there and figure out, oh gee, well, now is, oh gee, 3:34, but in the morning it's going to be 8:30 or 9:30, or maybe it's 10 at night. You shouldn't have to do that sort of thing, which is where mocking comes. I'll get into that a little bit more later, but let's take a look at the tests themselves. Here, we've got our unit test. I'm actually going to do some mocking here, and I'm going to use the patch method. There are other ways to do this. I just happened to go with this one because it was the easiest of the ones for me to start remembering. And I'll go into a few other points here. Here, we've got a test find found. As you know, we've got the requirement to name all tests starting with test underscore. And a good pattern is to say what you're testing there. And so we're testing the find function. And you should also, to help you figure out what's going on, rather than saying test 1, test 2, test 3, say a little bit more about what you're doing in the name of the function. So here we're testing that it found the file. And here we have the pattern of asserting equal, and we're actually hunting for this test file in the current path. That saves me some mocking. It's not ideal. But here we've also got one where I actually set up where I pass in the wrong type of matcher, where in this case I look and see if it's a directory. Now this one here should actually raise the exception that the code didn't find the file. Let's pull those back up. And see just exactly that particular deal. If we don't find it, we don't match against it properly, we get the runtime error. And so that test there, nice and simple, tests what we want. But oh gee, here I am. This is a point I don't like exactly about F8. It talks about using names all lowercase, lots of underscores. In Python, that's okay for methods for your classes at times, but there's something that I learned when using with a PHP unit, and at my previous job we had names where we said what we're testing, we had a condition in camel case that we were testing, and then we had what we expected. So it was test name, what we're testing, what we expect. Isn't this a little bit more meaningful name? Kind of hard to do that with underscores like this. But we've got the test here, and as you'd expect, they're fairly simple. And so here's where we apply the test and say, okay, I expect to find a directory instead. Artificial in this case, because I don't want to find a directory, I want to find a file, but this is how tests work. You sometimes set up weird conditions to execute branches of code that you wouldn't otherwise reach. And down here, we go into testing the other method. The other method, as you saw moments ago, we make a call, and if it throws an exception, we go with a default. And so here's where mocks come in handy. I don't have to rely on what's out there on the disk. I don't have to rely on what's in the database, so at times it's nice to go out to the database. And I'm not even going out to a web server that is out of my control. And this is also an interesting test where I'll show you something that I learned over the years and was really driven home in my previous position. Pattern of setting things up, running your actual test, and then asserting what you expect. Now, this isn't something that you can always do. In some test frameworks, such as PHP Unit, you set up your mocks and you set up your expectations and what's going to be returned and everything, and you actually have the assertions as part of your setup. But here we can actually do post-call asserts as well. And so we say that the assert called, or we can actually assert that the method find was called with our secret key file name that's our class constant. Down here, same thing, set up that we expect to get this path back. And this way we're only using it in one spot that we have it. We actually call the method to test it, and then we assert. Let's see how this. Again, we'll put reset to make things all nice and pretty, and run our test vault. And here we have 6 clean tests. We know that when we go into it, we have it finding the file, in this case our test file. We know that if we pass in something that isn't going to match, or if we have a different name that isn't found in our directory, it's going to raise the exceptions that we expect. And we have these passing as well. Now, I mentioned PEP8 and naming, and how if you use camel case instead on your unit test, it's a little bit more meaningful on your names. But there's another thing that comes into play on writing your unit test. There's the concept of mocking. In the video, he talks about how mocking is hardly ever used. Well, if you hardly ever use it, that's more of an integration test than a test of just a unit, because what is your unit? And your selection of unit is important here. Is it your single method? Is it your entire class? Is it your entire application? You know, here we're actually making calls out to other classes, like OS path. Now I could mock that one out, but I don't. It's easy enough to handle because it's very deterministic on what it returns. Particularly given that I'm running in the same directory, and it's consistent across that, depending upon whether or not I have this over in temp or if I have it in a directory under my home directory, I do here. But there are instances where you really need to mock out, call in a database, or creating other files, things of that nature. But you don't want to divide things down too smallly necessarily. It's a balancing act. You try to test a method that calls so many other methods in a class that you're talking thousands and thousands of lines of code being executed with a single call, or you sit there and only test the individual method. It's a difficult act to do, too. You end up with either too complex tests, or you, on the other end, end up what I refer to as flying pigs or flying boulders. And unfortunately, when you go to the extreme of testing things too minutely, And I would actually argue that in this case here, I did things actually at too high of a level and should have possibly done it down at the lower level, where I was actually mocking out the OS um, path method. Instead of mocking there, I decided to mock it at the find function. Now that's okay. Find's actually just a really simple function. And it has a really simple return, really simple call pattern. But it's possible to sit there and say, oh gee, find his wings, the wings flap, and they create lift, which makes you to fly, but then patch that method onto the pig, which doesn't fly too well, or patch it onto a boulder, which happens to bring down the castle that's your entire corporate external website that brings in the money that pays your paycheck. So it's a complex balancing act. But that's it for now. Check out the comments on this video. I'll actually provide links to Corey's video that prompted the response that I've done here. And I'll also include links to the source code to exhibit this over in GitHub so that you can play around with it yourself and get a little bit more familiar with this sort of thing. Thanks a lot for watching, and leave comments down in the bottom if you have any. Have a great evening.